Hello everyone, welcome back. In this video I am going over our Chapter 7 review to help us prepare for our quiz that we're having on Thursday. So the first two questions, they're asking us to write the first 6 terms of the sequence. So if you're being asked to write the first 6 terms of the sequence, remember a sequence is a list. You are not going to be adding these up or anything. To find the first 6 terms, you're basically asked to find what a sub 1 is, what a sub 2 is. So what I've done in the past is just made a table. You could make a table vertically or horizontally. I'm actually going to go horizontally. So n is going to be my input, and a sub n is going to be my output, and I'm substituting 1, 2, 3, 4, 5, and 6. So if I substitute 1 in the place of n, 2 times 1 is 2, minus 4 is negative 2. If I substitute 2 in for n, 2 times 2 is 4, minus 4 is 0. If I substitute 3 in for n, 3 times 2 is 6, minus 4 is 2. Substitute 4, I get 2 times 4 is 8, minus 4 is 4. Substitute 5, 2 times 5 is 10, minus 4 is 6. Substitute 6, 6 times 2 is 12, minus 4 is 8. So my answer is just the list of terms for your a sub n. So negative 2, comma 0, comma 2, comma 4, comma 6, comma 8. So that is your first 6 terms of the sequence. And that's all you have to do. Number 2 is the same way, except instead of writing it in sequence notation, it's in function notation, but you're still going to do the same thing. You're going to find the first 6 terms. Since I have a little bit more room over here, I'm going to make a horizontal or vertical table. N is my input, but my output now, a sub n, I'm going to use this formula. So I'm going to need a little bit more room probably. 1, 2, 3, 4, 5, and 6. Okay, so I can zoom in a little bit. So I'm going to substitute 1 in the numerator and the denominator. So if I substitute 1 in my numerator, 4 times 1 is 4. And then substitute 1 in and here in the denominator, 1 plus 5 is 6. So I can reduce that to 2/3. So that's the first term in my sequence. Now substitute 2. 2 times 4 is 8. 2 plus 5 is 7. That cannot be simplified, so that's my second term. Now substitute 3. 3 times 4 is 12. 3 plus 5 is 8. That one can be reduced by 4. I can divide both of them by 4, which gives me 3 halves. So that's the third number in my sequence. Substitute 4. 4 times 4 is 16. 4 plus 5 is 9. That one cannot be reduced, so that's the fourth term in my sequence. Substitute 5. 5 times 4 is 20. And then 5 plus 5 is 10. We can simplify that to just 2. Now multiply 6. 6 times 4 is 24. And then 6 plus 5 is 11. That cannot be reduced, so that's my last term. So your answer is the list, not the sum. So it's 2/3, comma 8/7, comma 3 halves, comma 16/9, comma 2, comma 24 over 11. 1, 2, 3, 4, 5, 6. So that is how you write your answer. Moving on to number 3. So in number 3, you're writing the series using summation notation. So these next problems, 4 through 9, are all written in summation notation. So those are good examples. So we're going to write our rule. It's going to look like this, but we have to figure out what's happening. Well, your first term is negative 5. The second one is positive 25. The third one is negative 125. Well, hopefully you've recognized that 5 to the first power is 5. 5 to the second power is 25. 5 to the third power is 125. So it looks like we're taking 5 to a power. But the way that we're going to get the numbers to go from negative to negative and positive and alternating is if we have that negative inside the parentheses. So the rule is going to be -5 to the n power or the I power, whatever variable you want to use. So -5 to the first power will be -5. -5 to the second power would be +25. -5 to the third power would be -125, and so on. So now we're going to, so now that we got the rule, we have to write this part of it. So we have to write that sigma. Down here in the bottom, make sure this variable matches this variable. So if you're going to use n, this should be n equals 1, because the first number we would substitute would be 1 in order to get the -5. But this ... here means that this is never going to end. So this is means we're going to have an infinite series. So we use the infinity sign at the top. So 1 to infinity, -5 to the n power. Now we've written our equation or our series in summation notation. So you've got to just figure out what the rule is, what the pattern is, and make sure it works when you substitute 1, 2, and 3. And then if it's ... you need to have the infinity sign at the top. All right, moving on to 4 through 9. Now 4 through 9, the directions just say find the sum. Well, you've been given some formulas. And the formula sheet, there is a formula for all of these sums, or all of these series, except for this one. So if you notice, 2 is it's supposed to be equals, so k equals 2 through 6. So you're going to be substituting 2 through 6 in for k, but you're finding the sum. So it's very similar to numbers 1 and 2. The difference is that you're going to now be adding these numbers together. So I'm going to make a table again. K is my input, and then A sub k, I guess, is going to be my output. But I'm going to start with 2. That's your lower limit. So plug in 2, 3, 4, 5, and 6. So if I substitute 2, I'll show my work on the right. So 2 squared minus 7, then I have to take 3 squared minus 7, 4 squared minus 7, 5 squared minus 7, and 6 squared minus 7. So 2 squared is 4, minus 7 is -3. 3 squared is 9, minus 7 is 2. 4 squared is 16, minus 7 is 9. 5 squared is 25, minus 7 is 18. 6 squared is 36, minus 7 is 29. So once we have these numbers, we're not going to just make a list.
Go back to detention hall.
Okay, pardon that interruption.
Please go back to detention hall.
So we're going to take our numbers here and add them up. -3 plus 2 plus 9 plus 18 plus 29. Because this says what is the sum of the numbers, the output values that we get when we substitute 2 through 6. So when we add those up together, we get 55. So that is our answer. And we're done with number 4. Now number 5, there's a rule for this. But we really don't need a rule. You should be able to figure this out because the output is always 1. So if every single output is 1 and we have 34 ones being added together, it's just going to equal 34. But the rule that we have that goes with that looks like this, and I think it's on your rule sheet. I equaling 1 to n of 1 equals n. So you can see that, whoops, I guess you have to see it if I pull it down. So this rule looks very similar to this rule, except it's k instead of I, and it's 34 instead of n. But your answer is just, the sum is just going to equal whatever your upper limit is, because you've got 34 ones being added together. So it's just going to equal 34. Good. Number 6, there's also a rule for this one. The rule for this one, let me write it down in blue. So the rule for this one says the sum of I equaling 1 to n of I. So whether it's just I or x, whatever your variable is, that variable is to the first power. There's nothing added or subtracted or multiplied to that variable. The rule is that the sum is equal to n times a1 plus a sub n divided by 2. So that's the rule. That's our formula. So if we look at what we're given, n is 15. You can see that we have I to the first power just like this, and we're going to have to figure out what the first term and the last term in our sequence is. So the first term, so a sub 1, is just equal to 1. So you're just plugging 1 in for I, so your output would just be 1. The 15th term, if you plug in 15, you just are going to get 15. And then you add that together, divide by 2. So you have 16. Oops, I forgot n. I can substitute n is 15. So when I add my 1 and 15 together, I probably should go back here and say 1 plus 15 divided by 2. So I get 1 plus 15 is 16 divided by 2 is going to be 15 times 8, and 15 times 8 is 120. And I just realized that's the rule for an arithmetic sequence, which actually will work because this I to the first power is a linear expression, so you can use the same rule for for the sum of just a variable to the first power, and you can use the same rule for like number 8, which is a linear expression. So this is the same rule that we would use down here. I should probably show you the other formula. So yeah, I'm going to use this space here. Okay, so I kind of made a mistake there. I used the wrong formula, but we're still going to get the same answer. So here's number 6 again. So in number 6, we're finding the sum of I equaling 1 to 15 of I. And the formula on the formula sheet says I equaling 1 to n of I equals n times n plus 1 over 2. So this is the formula that you were given on the formula sheet when your rule here is just I to the first power. So if I plug my 15 is still my n. So if I substitute 15 for n here and here, I'm going to have 15 times 15 plus 1 divided by 2. So the 15 times 15 plus 1 is 16 divided by 2. I could reduce the 16 by 2 and get 15 times 8, which again is 120. So using this rule or using this rule, I got 120. And again, that's because this is a linear expression. So it is going to be an arithmetic sequence, but it's a special sequence also. It's a special sum. All right, so there we did number 6 two different ways. Number 7, we have k squared, and we have a 9 up here, so our n is equal to 9. Our rule is k squared. So if you look on your formula sheet, is there a formula to find the sum of something that's just a variable squared? Well, yes, there is. And the rule for that is I equaling 1 to n of I squared equals n times n plus 1 times 2n plus 1 all divided by 6. So this is your rule or your formula that we're going to use to find our sum. But instead of I squared, we have k squared. But our n is going to be 9. So we have to substitute 9 for all those n's and then simplify. So if we put 9 in for n in all 3 places, we would have 9 times 9 plus 1, which is 10. 2 times 9 is 18, plus 1 is 19, over 6. So if I multiplied that numerator together and then divide by denominator, or just do this in the calculator, 9 times 10 would be 90, times 19 divided by 6 is going to equal 285. So that's our answer. Okay, so when you're taking your quiz, you're going to be given the formulas, but you have to know which formulas to use for what. And again, it comes from looking at the rule. So if you look at this rule, this is a linear expression because your I is to the first power. So this one, we're going to use that same rule that we did over here, n times a sub 1 plus a sub n over 2. So it's basically your first term and your last term added together divided by 2. So the average of your first and last term divided by the number of terms. So again, our formula, I'm just going to put it over here. I equaling 1 to n times a1 plus an divided by 2. So this is the formula that we're using. Oh, I didn't mean to, it doesn't look like this. I'm making too many mistakes. It says S sub n equals. So it's basically, that's what this is saying, is the sum of the first n terms is equal to n times the first and last term added together divided by 2. All right, so there's our formula. So we need to figure out what n, a sub 1, and a sub n are. Well, your n is just your upper limit. So n equals 8. A sub 1, we're going to have to figure out by substituting 1 into the rule. So 3 times 1 minus 7. A sub 1 is going to equal 3 minus 7, which is negative 4. So there's our a sub 1. To find a sub n, and n is 8, we're actually finding a sub 8. So we're substituting 8 into our rule. So we're taking 3 times 8, 24, minus 7, which is going to equal 17. So we have our a sub 1 equals negative 4, a sub 8 equals 17. So now that we have n, a sub 1, and a sub n, we can now plug it into our sum formula. So the sum of the first 8 numbers is going to equal 8. Again, we got the 8 from our upper limit. That's our n. And then we add the first and last terms together. So negative 4 was the first term, and then 17 is our last term, divided by 2. So this is going to give us, oh no, it's not going to give us a decimal because we could reduce the 8 and the 2. The negative 4 plus the 17, so we've got 8 times basically 13 over 2. So the 8 and the 2 we could reduce and get 4 times 13. So 8 divided by 2 is 4, but you still have to multiply by the 13, which will equal 52. All right, so that's the answer for number 8, and we're running into number 9. Okay, so again, we look at our rule to determine what type of series or sequence this would be. Well, if you look at it, this looks just like the geometric sequence. You've got your a sub 1 there, your r, which is your ratio or your base if it was an exponential equation, and then your exponent is I minus 1. So all the pieces that we need are right here. The formula, I'm going to write it down, so S sub n equals a sub 1 times, in parentheses, 1 minus r to the n power. And again, you have these formulas on your formula sheet, so you don't have to necessarily write them down, but I'm writing them down to use in my instruction. So the a sub 1 is just negative 3. Your r is the 2. And then your n is your upper limit. So we can get everything that we need right from the summation notation. We don't have to calculate the first and last term like we did with the last problem. So now I can substitute n with 4. A sub 1 is negative 3. And then 1 minus r, which is 2, to the nth power, and n is 4, over 1 minus r, which again is 2. Try to do as much math as you can mentally, because people make a lot of mistakes when they put too many things in the calculator. So the 2 to the 4th power I can do mentally, that's 16. 1 minus 16 would be negative 15. And then 1 minus 2 in the denominator would be negative 1. So the negatives divided by negative is positive, so that's going to be negative 3 times a positive 15. So s sub 4 is going to equal negative 45 when I multiply the negative 3 times the 15. And that's our sum of the first 4 terms. And that's the end of number 9. Number 10. So in number 10, we're writing the rule for the nth term of the sequence. So they're not telling us what type of sequence it is. They're just telling us to write the rule for the nth term. So we have to determine what type of sequence it is. So we have to figure that out. Well, if it's an arithmetic sequence, then there's going to be a common difference. So if I subtract right to left, 0 minus a negative 2 is going to equal 2. Negative 2 minus a negative 4 would also equal 2. Negative 4 minus a negative 6 would also equal 2. So we are going to have an arithmetic sequence, and our common difference is going to be 2. But in case you didn't get that, 0 minus a negative 2. So if I take 0 minus the negative 2, the double negative becomes plus, which gives me 2. If I do the next one, negative 2 minus a negative 4, again, the double negative makes that positive, so a negative 2 plus 4 is going to be 2. So hopefully you can see from those two examples our common difference, or D, is going to equal 2. What else do we need? We need to figure out the first term. Well, you're given the list, so the first term is given right there. A sub 1 is equal to negative 6. The rule is also on your formula sheet. So an arithmetic sequence, so this is arithmetic or arithmetic, however you want to call it. The rule for an arithmetic term for the nth term of a sequence is a sub n equals a sub 1 plus n minus 1 times d. So now we're writing the rule for the nth term, which means the n is going to be part of our equation. So rewrite this a sub n, but now substitute your negative 6 for a sub 1. N is again a part of our equation. Our common difference is 2. With arithmetic sequences, you do have to simplify this. So we're going to distribute the 2. So that will have negative 6 plus 2n minus 2. And then combine like terms, put the 2n in front. Combine like terms, we get negative 8. So a sub n is going to equal 2n minus 8. So that is our rule to find the nth term of the sequence. But then, after it says write a rule, then find a sub 13. So we wrote the rule. Now we're supposed to use the rule to find the 13th term. So you're going to put 13 in place of n. So 2 times 13 is 26, minus 8 equals 18. So a sub 13 equals 18. So that's the second part. Now in number 11, instead of an arithmetic sequence, I'm guessing it's going to be a geometric sequence. But how do we know? In order to determine if it's a geometric sequence, instead of subtracting, you're going to divide right to left. So if I divide the negative 512 by the 128, that is going to equal negative 4. If I do the same thing with the next two terms, 128 divided by negative 32, that also equals negative 4. And negative 32 divided by 8 also equals negative 4. So our common ratio is negative 4. That's also going to be the base in our exponential expression. Okay, so what else do we need? Well, the geometric sequence, the rule to find, or the formula to write the geometric sequence is a sub n equals a sub 1 times r to the n minus 1. So since we're writing the rule that for the nth term, n is now part of our equation, but a sub 1 we are given. Just like in the last problem, if you're given the list, the first term in your list is a sub 1. So that 8 is going to go in the place of a sub 1. The ratio, which we just found, is negative 4. So our rule, a sub n equals 8 times negative 4 to the n minus 1 power. So that one's not too hard to write since we don't have to simplify anything. We just plug in the a sub 1 and the r. But then it says find a sub 6. So once we've written our rule, we're going to substitute 6 for n. So if we take 6 minus 1, we're going to get 5. So 8 times negative 4 to the 5th power. And again, you can just plug that in the calculator. Take 8 times 4 to the power of 5. So make sure that negative 4 is in parentheses, and then caret 5. And you should get negative 8,192 for your answer. Oops, let me move it over so we can see it. Okay, so there's our answer for number 11. All right, now we're going to move on to number 12. So in number 12 and 13, again, they're giving you a list. And you have to determine, if you look at the choices, they're saying the sequence is geometric, the sequence is not geometric, the common difference is negative 0.2, or the ratios are not constant. So you've got some geometric, so you got to figure out, is it geometric or not, first of all. So if I divide right to left, again, you can use the calculator for that. But if I divide right to left, 0.2 divided by negative 5.6, let me grab a calculator because I don't see, oh no, there it is equal to negative 0.357. And then if I try the next two terms, if I divide the negative 5.6 by the negative 9.4, well, I can already tell that's going to give me a positive value. So that is definitely not geometric, because here I got a negative value, here I'm going to get a positive value. But if I did plug it in the calculator, I would get a positive 0.596. So that is definitely not going to be geometric. They're not even close to being the same. So we can cross out A. Well, is there a common difference? So for that, we have to subtract right to left. So since I already used the space to divide, now I'm going to subtract. And again, you can save space by just plugging it in the calculator. So if I take 0.2 minus the negative 5.6, the double negative is going to be positive, and then when I add, I'm going to get 5.8. If I subtract it again, I'm going to write this up here where I have a little more room on the top. So if I take negative 5.6 minus a negative 9.4, again, that double negative is going to become positive, and that's going to give me 3.8. So again, nothing is the same. There is not a common difference. So they're saying the common difference is negative 0.2. That is not correct. The sequence is not geometric. Well, we already determined it was not geometric, so that is a true statement. And the ratios are not constant, which we already determined that also. So both C and D are true statements. It is not a geometric sequence, and the ratios are not constant. Okay, look at number 13. So I can kind of tell already, negative 30 or negative 64 divided by 32 is going to be negative 2. 32 divided by negative 16 is negative 2. Negative 16 divided by 8 is negative 2. So once again, if I divide, it's going to equal negative 2. If I divide 32 by negative 16, that's going to equal negative 2. If I divide negative 16 by 8, that's also going to equal negative 2. So I am going to have a common ratio, so it is going to be geometric. So we have a true statement here. The sequence is geometric. This could be our rule because it does have a negative 2 here. And we look at our first term in the sequence, it is 8. So this is also going to be true since our first term is 8 and our ratio is negative 2. So that is going to be true. Well, let's see, are these other ones true? Well, they're saying the 8th term in the sequence is 2048. So how can we figure that out? Well, the way to figure that out is by writing our rule, or taking our rule, which is already right here, and substituting 8 in for n. So let's try it. Let's see if we do get 2048. So a sub 8 is going to equal 8 times negative 2 to the 8 minus first power. So that's going to be 8 times negative 2 to the 7th power. And again, if I just plug that in the calculator, I get negative 1024. So that is not the same as 2048. So that one is not a true statement. But that's how you would figure it out, by plugging it in. All right, the last statement says the sum of the first 8 terms is negative 680. So we need the sum formula. So the sum formula for geometric sequence S sub n equals a sub 1 times 1 minus r to the n over 1 minus r. Whew. All right, so 8 is our n that we're plugging in. So we're going to plug in n there and there. So S sub 8 is equal to our first term, which is 8, times 1 minus r, which is a negative 2. So be careful, put parentheses around that negative 2 to the 8th power over 1 minus our rate, which is, again, is negative 2. So we're subtracting a negative. But in the numerator, you must do the exponent before you take care of this subtraction. All right, so I'm going to keep showing my work over here. So I've got 8 and then 1 minus, well, if I'm taking a negative number to an even power, that is going to actually end up being a positive number. And if I calculate 2 to the 8th power, that's going to be 256. So negative 2 to the 8th power is 256, but you still have that minus in between. In your denominator, though, you don't have an exponent. So the double negative will make it a plus. 1 plus 2 is going to equal 3. Okay, so now I'm going to continue simplifying this. If I divide, or the 1 minus 256 is going to be a negative 255. If I divide, oh, here, off the screen. If I divide negative 255 by 8, that's going to equal negative 85. So when I multiply the negative 85 by 8, I get negative 680. So S sub 8 equals negative 680. And is that what we had in our statement? Yes. So A, B, and C are all true. Again, going back here, if you wanted to see the work, there it is. Okay, moving on to number 14. In number 14 and 15, you are writing the rule for the nth term of the sequence again, and then you're going to graph the first 6 terms of the sequence. So looking at the information they're giving you, they don't really tell you what kind of sequence it is, but they tell you D equals negative 4. Well, the only type of sequence that has a D, or a common difference, is arithmetic. So we're going to be writing an arithmetic sequence. So that right there tells you it's arithmetic or arithmetic. If you look at number 15, they're giving you a R. So that R tells you that you're going to be writing a geometric sequence. So they're giving you the 12th term of this sequence is negative 36, and they're telling you the common difference. But in order to write the rule for the nth term, we have to know the first term, because again, our rule, a sub n equals a sub 1 plus n minus 1 times d. So we don't know a sub 1, but we can find it by using 12 for n, and then negative 36 is going to be our a sub n. So 12 is the input, negative 36 is the output. So put negative 36 in place of a sub n. We don't know a sub 1. N is 12 minus 1 times our common difference, which is negative 4. Subtract, since we can calculate that, 12 minus 1 is 11, times negative 4 will be negative 44, plus a sub 1 equals negative 36. So the a sub 1 is being added to the negative 44, so that negative 44 has to be added then to cancel it out. And we get a positive, I think it's 8, yeah, 8. So a sub 1 equals 8. So now that we know a sub 1 and we know our common difference, we can then write our rule for n. So the n now is part of our equation. A sub 1 is 8 plus n, again, is part of our equation, minus 1 times d, which is negative 4. But again, with an arithmetic sequence, you want to simplify it. So that negative 4 needs to be distributed. Bring down your 8. The negative 4 times the n will be a negative 4n. Negative 4 times the negative 1 is going to be a positive 4. Put the negative 4n first, combine your like terms, and you'll get plus 12. So a sub n equals negative 4n plus 12. Okay, so there's our rule for the nth term of the sequence. Now we need to graph the first 6 terms. So I'm going to use this space over here to do the table. So 1, 2, 3, 4, 5, and 6. Well, we already know the first term is 8. We already figured that out over here. So now we're just going to, let's substitute these in the calculator. 2 times negative 4 is negative 8, plus 12 is 4, or just figure them out mentally. If I substitute 3 times negative 4 is negative 12, plus 12 is going to be 0. 4 times negative 4 is negative 16, plus 12 is negative 4. 5 times negative 4 is negative 20, plus 12 is negative 8. 6 times negative 4 is negative 24, plus 12 is negative 12. So now that I have all of my terms, or my points, I can put them on my graph. But remember, this is not a consistent, or it's not a continuous function, which means you do not connect the points. Just graph the points, the 6 points. So 1, 8, so notice you're going by threes here, so 8 is going to be about right there. 2, 4, maybe right there. 3, 0. 4, negative 4 is going to be about right there. 5, negative 8, about right there, and then 6, negative 12. So they do look like they're linear, looks like it's going in a straight line, but do not connect the points. Okay, moving on to number 15. So in number 15, we are finding a geometric sequence, or we're writing a geometric sequence. This is our third term of our geometric sequence, but again, for the rule, a sub n equals a sub 1 times r to the n minus first power. So there's your rule. So we need to know the first term. Well, we know our r, but we don't know the first term. So we can find it by using the information here. So n is going to equal 3. That's our input. Our output, a sub n, is going to equal 12. So we're going to plug 12 in for a sub n and 3 in for n. And then we can solve for a sub 1. So a sub n is going to be 12 equals a sub 1, which we don't know. R is 2, and then n is 3. So 3 minus 1 is going to be 2. So 12 equals a sub 1 times 2 to the second power, which is 4. So 12 is equal to a sub 1 times 4. Divide by 4, and we get a sub 1 equals 3. So now that we know a sub 1, we can now write our rule. But it's the rule for the nth term, which means n is part of our equation. Put 3 in for a sub 1, put 2 in for r, and then n again is part of our equation, so it's n minus 1 here. So there is our rule. Then it says, then graph the first 6 terms. So again, I'm gonna make a table. Yeah, I probably shouldn't have put that line there. Oops. So let me just erase that line. So I'm gonna use this space for finding my terms. All right, so again, we're going to substitute 1, 2, 3, 4, 5, and 6 into this rule. So, yeah, I need more space. All right, so it's going to be 3 times 2 to the n minus 1, or 1 minus 1 power. That's going to be 0. 2 to the 0 is just 1 times 3 is 3. But we already knew that. 1, 3 was our first term. If I calculate the next one, I'm going to take 3 times 2 to the 2 minus 1 power. Well, 2 minus 1 would just be 1. 2 to the first is 2, and then times 3 would be 6. So now if you could continue substituting the 3 in for n and the 4 in for n and the 5 in for n, or you can see that your ratio is 2, which means we're going to, from one term to the next, you just have to multiply by another 2. So 3 times 2 is 6, 6 times 2 is going to be 12, 12 times 2 is 24, 24 times 2 is 48, 48 times 2 is 96. So those are going to be our 6 terms. So you can just multiply the previous term by 12. You can kind of also do that with the arithmetic sequence rather than substituting every single time. If you look at the pattern, or if you know that your common difference is negative 4, you would just subtract 4 each time. 8 minus 4 is 4. 4 minus 4 is 0. 0 minus 4 is negative 4. Negative 4 minus 4 is negative 8. Negative 8 minus 4 is negative 12. So that common difference and that common ratio can help you find those output values a little bit easier. All right, so now let's graph it. Notice your intervals here. You've got 30 here, so this is 15. So this would be 45. So they're going by 15s. So the 0.13 is going to be almost right at the bottom, just a little bit above the x-axis. The 0.26 is not even going to be a little bit below halfway, so just a tiny bit higher than the 3. And then 312 is going to almost be to the 15, but not quite. 424, make sure it's below the 30. 548, now we're getting somewhere. So 45 was right here, so 48 would be a little bit above it. And then 696 is going to be way, here's your 90, so 96 would be a little bit above that. So again, do not connect the points. They are separated, it's not continuous, but you can see if we did connect it, it would look like an exponential graph.